Hi everyone. The objective of this video tutorial is to show you how to generate RNA secondary structures in bulk. And this is the figure we're going to make today. There's 99 structures here. And basically what happened is we were trying to see how RNA structure changes on an mRNA. It was about 1,700 nucleotides wide when the organism is heat stressed. And somebody collected a whole bunch of DMS in vivo structure probing data, and I mapped the data to a secondary structure in 50 nucleotide windows. So if we zoom in here, we see our window from 1,000 to 1,050 nucleotides. And notice that there's no reactivity restraints. I folded it in RNA structure. Right next to it, we have the same window, 1,000 to 1,050, that's been folded with reactivity restraints from in vivo probing data at 20 degrees Celsius. And we have the same sequence folded at 42 degrees Celsius with 42 degrees Celsius reactivity data. Obviously the structure is totally denaturing. So the idea here is if you want to get a look at what your RNA are doing based on the data, and you want to print a lot of pretty nice looking secondary structures at once, there's some features built into my package R2easyR that can do this. So in order to make this figure, you're going to want to have two windows open. The first is an R window. I'm using RStudio because I like it. And the second is you need to have a bash terminal. I'm using Cygwin. Mac and Linux users have this easy. They can just use their terminal. This is the terminal I'm going to use to run R2R. So again, we're going to use R to generate inputs withdrawing information for R2R to make our eventual figure. So before you kind of get there, you're going to have to organize your data in a way that R can read it. So here I have a bunch of CT or connectivity table files from RNA structure, and I have them in order of how I want them to print. So 50 to 100 with no reactivity, and then 50 to 100 with reactivity straits from 22 and 42 degrees Celsius, and then the next window, and then the next window, and so on and so forth. And that's how I want the figure to print. And I have the reactivity data that I want to map here. It's shape formatted so that, and it's all in the same order as the previous file directory. And then finally, I have one more folder here. Right now it's full of stuff because I just copied and pasted it. But I'm going to delete everything. I want it to be empty for now. And that's because we're going to fill this with R2R inputs. So again, before you start this, you want to have your CT files from RNA structure. You want to have your R2R files, an empty folder for R2R input files, and your reactivity data in a different folder. So now we're going to get into the R. The first thing I'm going to do is just open up an R script in order to keep track of my code. And I'm going to save it in the directory video tutorial 3. I'm going to call it demo.r. So I'm going to save it right with my data. And I'm going to use session set working directory to source file location to set my working directory. I'm going to copy and paste this, what ran in the console when I did that, into my R script, just so I can save it for later. Next thing we're going to need to do is to download R2easyR, which is the package that you can use to generate R2R inputs. So to do that, I'm going to use DevTools, which is another R package that's it's a package for the development of R packages. And then I'm going to go DevTools : install GitHub. And then this will install R2easyR from the GitHub repository. So quotation marks, my username is JPSIEG/R2easyR. And it's going to shoot you some error messages because I'm not that good at making R packages. Taking a sec. Then you might get asked to update all of these packages. Don't do it. Just empty line of code. It takes forever, and you don't need to do it. And then here, it's installing. Still installing. Just installed all the functions, and now it's done. So our next step is we're just going to load our recent installation. You don't have to install it every time, but you do need to probably load R2easyR into your memory every time. Yep. And then now we're going to process our R2R inputs in bulk. And there's two kind of functions built into R2easyR that do this. The first is the first is ry.trna. If we run that !ry.trna, you get this. This is a highly specialized function for a friend of mine's data, a collaborator's data, and it's basically designed to take in vivo reactivity data from tRNA and map them to secondary structures and get that nice tRNA layout where it's upside down in bulk. So you probably don't want to use that. The second function that I'm going to show you how to use today is R2easy. Second function for processing things in bulks is R2easyR go fast. And here's the help file for that. And you can see that its usage is here. And we're going to need to specify a folder with the CT files. We're going to have to specify a reactivity folder with the shape formatted reactivity files. And we're going to have to specify a folder for the R2R inputs to go into. And there's a couple of other things here that we're going to talk about in a second. So first, I'm going to go R2. Well, first I'm going to use list.files so I can see which files I want to read. So here we have our CT files, we have our the empty folder for the R2R files, and we have a folder for the reactivity files. Now we're going to go R2easyR dot go fast. And the first argument is our CT folder. I'm going to go ahead and copy CT. Our next argument is our reactivity folder. So I'm going to copy reactivity. And our third argument is the folder we want the R2R files to go into. And then I'm going to do two things that are kind of important for the ultimate drawing. The first is I want to set an absolute reactivity threshold. I'm going to set that to 0.01. And this is so that really low reactivity data that's basically 0 is not cluttering up the figures. The next thing I'm going to do is to set a manual scale And I'm going to you supply a vector, so C parentheses 0, comma 2.5. And this will apply, this is the scale you want to use for reactivity data between structures. That way, the scale on every single structure is the same. Lastly, this really isn't an important parameter to set, but if you watch my other videos, you'll know that it prints a legend and a reactivity plot when it runs. The R2easyR, sorry, the R2easyR color function does this. And this is the structure that you want to make that on. And so the legend is going to be the same for every structure, but the reactivity plot won't. So I'm just going to make this 99. And then that's done. So I'm going to hit Control Enter and run the code. And right now it's reading in the data. So it just read in all the CT files and reactivity data. It generated palettes, and now it's generating R2R files. After it's done generating the R2R files, it's actually going to use R2easyR.stem _editor, and that's going to optimize the stem layout so that if you have two stems right next to each other, normally they would crash in default R2easyR, but the stem editor flips every other stem across the line of the backbone so that the stems don't clash. So that's what, well, we're done now. The functions run. There's some usage warnings, but that's from the ggplot steps. It's not a big deal. And now we can open up our directory and we can see we now have a whole bunch of new stuff. The first thing we have is a legend, which you can open up in Illustrator or some other drawing program and copy and paste next to your RNA structures. We have a reaction plot from, remember, we set this plot to be written on file 99. So here's what the data is going to look like on it. We have a list of palettes. And finally, we have a master R2R meta file. And that's what we're going to run R2R on. Now, if we look inside our R2R folder, we see, remember, I deleted everything and it was empty, and now it's full. And each one of these are a drawing instruction for a different secondary structure that was made based on the CT file and the reactivity file. So now we're done with the R steps, and I'm going to go to my bash terminal, and I've set the working directory. I'm going to use ls to look at the files, and this is the file I want to run R2R on, master.r2r meta. And I'm going to go R2R disable usage warning. And then the file I want to run R2R on is master.r2r meta. Ooh, I don't want that comma there. That would be bad. It needs to be a period. And then space, and the now I need a file name to write the PDF into. So I'm going to call it mrna.pdf. And then I'm going to hit go. And it's going to start drawing structures. And it's got to get through 99 of these things. So it'll take a couple seconds. Still going. And it's done. So now I can open up my directory again. And here we have a new PDF named mRNA. I double click it. And there it is. I've printed all 99 structures, and you know, this is a nice way to look at them. I think they all look pretty great. You you have the reactivity mapped to the right nucleotides, and this is a good way to see a lot of reactivity data on nice looking secondary structures all at once. Only what took us 15 minutes. And you can open this PDF up in Illustrator or another editing drawing program and copy and paste the structures that you actually want to put in a figure or put up on a slide in a presentation or on a poster, and set the legend next to it and all that stuff. And obviously you don't have to spend hours and hours drawing all this. So that's the end of my tutorial.